I'm going to go ahead and start by just presenting to you, this deck that I have. And this deck basically talks about the current and future of Jakarta EE as a technology. So a little bit of both. My name is Reza Rahman. If you're not familiar with me, in my day job, I work for Microsoft as Principal Program Manager for Java on Azure. So basically, I try to make sure that everything that Microsoft is doing is in the benefit of Java developers, and Java developers can have a good experience on Azure. But actually, today I'm representing more the Jakarta EE ambassadors, and I'll talk a little bit about what the Jakarta EE ambassadors are. Outside of my day job, I'm an author. I do blog and I do speak in places like this. So feel free to get in touch with me at any point in time. One of the reasons I do all of the speaking stuff is to connect with you, not just to make a presentation. So on screen, you'll see my email address and Twitter handle. Feel free to follow me or drop me an email or contact me in any of the other ways possible to have a chat about, whatever you want to talk about. Okay, so hopefully by now you've heard of Jakarta EE, and if you haven't heard of Jakarta EE, basically Jakarta EE is the technology formerly known as Java EE. So Java EE was transitioned from the JCP to the Eclipse Foundation. There's nothing per se wrong with the JCP. I've worked at the JCP for a number of years. But the JCP at the end of the day is not a separate organization. It's owned by Oracle. It's just a division of Oracle, if you will. And ultimately, everything that goes on in the JCP, a majority of it is actually owned, the IP is owned by Oracle and Sun prior to that, when the JCP was part of Sun. As opposed to that model, with the Jakarta EE and things moving to the Eclipse Foundation, really it is a separate entity. It's not a for-profit organization. It's a non-profit organization whose core mission is to foster open standards and open source. And no one really owns the IP. Right? So the IP ultimately goes to the Eclipse Foundation, but it's a far more fair and much more balanced ecosystem. Really, everybody has a level playing field when you're dealing with IP that is ultimately controlled by the Eclipse Foundation, a non-profit entity. So what that means is completely open governance, open source, even all the way down to the compatibility testing. For years, the TCK, or the compatibility test kit for Java EE, was closed source, not open source. So that is open source now. Right? So it's a completely open regime. If you want to be Jakarta EE compatible, all you need to do is go and download the TCK and run the TCK and say, hey, yeah, I'm certified. So it's a much more different ecosystem. And certainly the Eclipse Foundation has a long history of being pretty vendor neutral and doing exactly those things. So doing open governance, doing open source, and the like. There's still some process, though. So this is not like just an open source project, if you will. So there is still a well-defined specification process. So all of the things that were there before, the good parts, like having the specification process, having clear IP flow, being vendor neutral, and being implementation neutral, all of those things still remain with Jakarta EE, and many of the key stakeholders still also remain. And in fact, if you look at Jakarta EE9, Oracle, although it's donated Java EE to the Eclipse Foundation as Jakarta EE, still continues to be actually the primary contributor still. And actually, the second largest contributor is people like us, people in the community, and we'll get to that point next in a moment. But there's also IBM, Payara, Pivotal, all these names and brands that you're already familiar with. They're still also very much engaged in Jakarta EE, and hopefully strengthening it going forward. But the key thing to understand, and I hope the reason you are here, is actually because what is going on with Jakarta EE really opens up the door in terms of contribution from people like us, right? So it really levels the playing field. Anyone can contribute and have a significant impact on Jakarta EE. And this is an opportunity. It's a historic opportunity of having such a large impact on such an important part of the Java ecosystem. So it's very, very important that we all understand it and hopefully contribute towards the future of this technology. So if you want to find out more about Jakarta EE, the best place to do that is the website that I listed here. It's jakarta.ee, and you can feel free to log on there and find out whatever information that you would like. Now, one thing that I forgot to mention, and I should say, is this particular slide deck is actually intended to be shared, right? So, in other words, if you want to present this talk, you can feel free to take the slide deck and present this talk. So the source is available on the Jakarta EE Ambassadors website. You can download it. You can certainly attend the talk today. You can get help from people like me and other ambassadors, and maybe you can present this talk at a conference or a Java user group, or even internally at your own company. So in this slide, we want to talk a little bit about the evolution of Jakarta EE as a technology. It's certainly not a young technology. It's been around for quite a while, basically since the mid-90s. It started its life as JPE. I don't know how many people still remember what JPE is, but it stands for Java Professional Edition, right? So in the very beginning, that was the acronym that was used for Java EE. Then it became J2EE, and it remained J2EE for some years. And this is where a lot of people still have an idea of J2EE or Java EE. They're kind of still thinking about J2EE as a technology. But the reality is the technology set has moved on from that for a very long time. Right, so now it's there's been Java E5, Java E6, Java E7, Java E8. Right? These are all technology sets that have evolved and evolving. Right, so there's different evolutions that have happened, like embracing the POJO model, bringing CDI into the ecosystem, embracing annotations, adding all these interesting APIs like WebSocket, concurrency, batch, Jakarta REST, bean validation, and the like. Jakarta E8 is the first release under the Eclipse Foundation, so under open source governance model. So other than the governance model, it's actually basically the same technology as Java E8. So Java E8 and Jakarta E8 are binary compatible. They're the same technology set. The only difference is that Jakarta E8 has a completely open TCK, whereas not the case with Java E8. So that's been actually out for about a year now. So you can actually begin to adopt Jakarta E8, and I hope some of you already have. Which brings us to Jakarta E9, and we're really at the cusp of Jakarta E9. Almost all of the work has been done. It's any day now. It'll be released. In fact, the first candidate release is already out there. It has been out there for a few months now. So you could begin to evaluate, adopting Jakarta E8 as well. So Jakarta E9 as well, pardon me. So as you've seen, the name had to change when things moved to the Eclipse Foundation. So it moved from Java EE to Jakarta EE. Similarly, what's happening with Jakarta E9 is the namespace is also changing. So the namespace used to be Javax. Now the namespace is going to be under the Jakarta regime rather than the Javax regime. And basically, this decouples the IP completely from Oracle, right? So this is truly owned by the community in all senses, including all of the code base, including the naming, including the branding, including namespace and everything. And that really primes things to move it forward onto Jakarta EE10 going forward. And we'll talk a little bit about what exactly is in Jakarta EE10, maybe towards the end of this presentation or slightly thereafter. So we have a couple of hours, and I do plan to keep it a little bit interactive. At least I hope you'll be encouraged to interact with me and answer any questions that you might have. So I think I would like to stop here and basically take any questions, gauge how you all are doing before we jump into this slide, which is about Jakarta E8. So what I found is because of all of the things that have happened between the transition, with the transition from Java E8 and Jakarta E8, Jakarta E8 actually hasn't been evangelized very much. So not a lot of people actually know what is possible today. And that's really a shame, because Jakarta E8 at heart is a very, very capable platform, especially if you're writing mostly just a monolithic application. It's a really good platform to go with. So we'll see why that is in a second, and we'll also see what the changes are in the platform. But before we do that, let me just gauge what is going on, and also maybe give you an opportunity to do a little bit of Q&A. Okay, so I don't see any questions posted as of yet. So we're just going to continue moving forward. I hope that you will have some questions, and you will post your questions. Please do post your questions on the chat, and then maybe we can have a dialogue. Again, I can bring you on screen, and we can have a real-time chat. Just like we would at a booth. So these are the things that are there in Jakarta E8. First and foremost, a lot of web standards alignment. A lot of things are actually happening these days outside of the Java ecosystem. In particular, the JavaScript ecosystem. And believe me, the JavaScript ecosystem is also very, very vibrant, and there's a lot of things going on just in that ecosystem as well. So these are things like HTTP2, server-sent events, JSON. I don't know how many people know this, but JSON is actually a W3C standard as well. So all of these things are evolving, and we need Java developers to be enabled so that they can actually take advantage of all of these innovations. So these sorts of changes in Jakarta 8, the aim is exactly that. Right? The aim is to take all of these innovations and bring them into server-side Java, so that you all can take advantage of all of these innovations. And we'll talk about some of these things later on in the presentation as well. Other big theme is CDI. CDI actually has been a major theme since about Java EE 6. But since Java EE 6, really you had very minor releases of CDI, right? So for minor point releases, CDI 1.1, CDI 1.2. In Jakarta 8, you actually had a major release in CDI 2, and again, I'll talk a bit about that as well. But aside from CDI 2, the standard itself, other parts of Jakarta E actually has absorbed bits and pieces of this technology as well, right? So other technologies like JSF managed beans, faces, all of these have made their own alignment. So some examples of this is that the JSF managed bean model was entirely pruned, right, in favor of CDI. Now you can inject more CDI artifacts as JSF injectables, right? So all of these things like faces context, you no longer need to look those up. You can simply inject them. Similarly, the JPA or Jakarta Persistence has taken advantage of some of these things as well. Now, one thing that I'll notice and I'll note here is those acronyms that we used to use, they're actually no longer in use anymore. So we used to say things like JPA and JAXRS and JSF and the like. So in Jakarta E, what has happened is we've also dropped all these acronyms, right? And also this is part of that same concept of decoupling the branding. So now you have full names, right? So instead of saying JPA, you can simply say Persistence or Jakarta Persistence. You can simply say Jakarta Faces. You can simply say Jakarta REST, right? So that's the model that you'll actually see me following in this slide deck as well. Now, simplicity is another theme, and simplicity has been a theme even prior to Java EE 6. So it's been a theme since Java EE 5. The biggest example of this in this case is security. So we always want to take a look at every part of the platform and make sure that it is as simple as possible. So we'll talk about what the security simplifications are a little bit later in the presentation. And the other bit of simplicity is pruning the EJB model. So we basically got rid of some of the really old stuff in EJB, for example, the JAX RPC bindings and the entity bean bindings. So those have officially been pruned as of Jakarta E8. And finally, Jakarta E has always made a point of adopting innovations, not only from Java SE, actually from the larger ecosystem, but most certainly from Java SE, right? So some key examples of this is things like annotations. I don't know how many of you know this, but Java EE 5 was actually the main technology to bring annotations into the mainstream. All of the other frameworks and all the other technologies were after that, after Java EE 5 adopted the concept of annotations and POJO modeling, essentially. So similarly, Java SE8 also has some very good innovations. So these are things like repeatable annotations, datetime API, streams, completable features. In fact, things like repeatable annotations were specifically designed for adoption into Jakarta E. But all of these other good, solid innovations, Jakarta EE also needed to take advantage of, right? So that again, those technology use cases become mainstream and become fully available to enterprise Java developers. So some of the technologies that have adopted in this way, the Java SE8 features are Jakarta Faces, Jakarta Persistence, REST, and bean validation. And we'll see that in a moment, how that is as well. Okay, so now let's begin a general tour of Jakarta E8. So the best place to start this tour is actually the servlet specification, or Jakarta Serviet 4. This is one of the foundationally important, probably one of the most important things that are in Jakarta E8, and as to why you should really consider adopting it. And the key objective in Servlet 4 is really adopting HTTP 2 support, right? That's the primary thing. That's the reason for having the standard. And if you haven't seen HTTP 2, you really should, right? So this has been a long time in the making. It's almost the first revision of the HTTP specification in almost 15 years. And its basic objective is to align the protocol with the way the web is today, right? So in order to understand what these changes are, you'll have to take a time machine trip back to me about 15 years ago, in the very beginning of the web, when you had things like NSCA Mosaic or perhaps Netscape, right? So how did the world look like back then? How did the web look like back then? So the web of that age looked a lot like a set of Wikipedia pages. So if you look at Wikipedia today, that's the web of basically the early 90s or even before that, right? So it's basically a set of pages, right? So you pull up a page, and it's mostly self-contained. There's just a bunch of text. There's a little bit of text formatting, and that's really about it. There's not a lot of images, maybe one or two images here and there. And principally text and hyperlinks, right? So you click on one thing, and then you go to another page that looks exactly the same way. Like it's a bunch of text, a little bit of images, and hyperlinks, and that's about it. So in that world, the model that HTTP 1.1 followed really made a lot of sense, right? So in HTTP 1.1, it's really based on single request and single response, right? So you make a request to a page, and the server gives you that page. And if you happen to need an image, you make another request and you get the image back. And that works perfectly fine, right, in that world. Now, if you fast forward back to where we are today, the web of today looks very, very different than the web, the way the web used to look like. So so Google did a little bit of a study on this, and basically they found out that on an average page, there's about 40 different resources that page depends on to render itself, right? So these are things like CSS, JavaScript, images, video, embedded content, and the like, right? So what's happening is, using HTTP 1.1, it's a fundamental bottleneck, right? There's a paradigm mismatch, and that paradigm mismatch causes a lot of performance issues, or at least perceived performance issues. So basically what HTTP 2 does is that it breaks down that fundamental paradigm and says, okay, let's reimagine the protocol in the way that it would make sense in today's world. So first and foremost, the main changes are that it no longer opens up a connection again and again. There's no longer a set of requests and responses that happen. It's really just one connection, right? That is opened once between the client and the server, as you can see in my little diagram here. And basically, you reuse the same connection to exchange a bunch of information, namely a bunch of logical resources broken down by stream, right? And for those of you who are familiar with TCP/IP, this is a very normal model, right? This is the canonical model of how TCP/IP actually works, right? As you have one connection and you break things down into various streams, each stream representing a resource. So this is really how HTTP 2 works. And not only does it work this way, another parallel with TCP is that it is no longer a text-based protocol. It's actually binary-based protocol, right? Which again goes towards improving performance by essentially eliminating serialization and deserialization overhead on both the client and the server end. In addition to that, there's other optimizations. So there's things like when you have these multiple streams, each of these streams is actually given a priority, right? So maybe the text and the body of the request is given more priority as opposed to images that are maybe given slightly less priority, right? So the server and client don't need to open up sequential connections. They can open up as sort of parallel streams and then prioritize those streams accordingly. There's also something called header compression. So this is based on the observation that when you have a set of related resources, the HTTP headers that are exchanged between the client and the server are actually mostly the same. They don't differ very much, right? So taking advantage of that fact, you can eliminate some of the redundant headers and only exchange things that actually make sense. So maybe things like the name of the resource or the size of a particular resource, and that's really about it. Right, so that's what about header compression. And the final notable optimization that's in HTTP2 is something called server push. And what this is that taking advantage of the knowledge that the server has, that, okay, if you want to load this page, you're going to need all of these other dependent resources. So instead of the browser parsing through that page and making those requests one by one, the server just says, hey, you requested this page. I know you're going to need all these resources. Here they are. I'm going to push it to you into the cache right away so that you don't have to explicitly request it. And the moment you need it, it'll just be there for you. And so these are all, that's what server push is about. Now you'll notice another important thing about HTTP2 is that it actually does not change the API. The HTTP2 API looks exactly the same. All of the changes are mostly in the implementation layer. Right, so in how the API is implemented. So what that means for Servlet is that Servlet 4 does not actually need to change its API very much. Right, so all it really needs to do is guarantee that a Servlet 4 implementation is going to correctly implement HTTP2, and that's actually very important, right? So when somebody is getting certified with Servlet, you're guaranteed that you have a good implementation of HTTP2. The one API change is that server push. Right, so in the server push, you can't do that automatically. You do need to take a proactive step to flush down those resources, right? Those dependent resources. But that is also opt-in, right? So you need to explicitly make a change to your code to take advantage of that feature. If you don't add that code, nothing happens, right? It's a non-breaking chain, non-breaking upgrade to Servlet 4. And actually, if you're using something like JSF or a higher level web framework, JSF actually takes care of server push under the hood because JSF knows what the dependent resources are. So it will do the server push on your behalf, again, without you needing to make any changes. So if you have a JSF implementation and you're upgrading to Jakarta E8, you're immediately getting the benefit of server push without making any code changes. So Google did, again, a little bit of a research on the performance impact of some of this, and it actually improves perceived performance by the end user by about 5-fold, right? So that's a pretty significant performance improvement, largely without needing to make any code changes. So JSON binding is another very important change that was introduced in Jakarta E8. So this is basically a brand new API that was introduced. And it's important to understand the context of why this API was introduced, right? So if you look at Jakarta EE or even Java SE today, it actually comes with a set of protocols that allows you to serialize and deserialize data. In other words, take data from a file system or take data from an external system and consume it within Java and vice versa. So some of these serialization mechanisms are Java serialization is one of them, of course, but also XML, right? XML is baked into the platform, so you don't have to do anything else. It's just sort of there with the recognition that, okay, this is a first-class data format that we need to support for server-side Java developers. Now, in today's world, JSON has largely displaced everything else as the data serialization format, and it's not just about JavaScript, right? And pretty much everybody has agreed that this is a data format that they want to use in order to do data interchange on the web. Okay, so when that happens, you need to do something in the server-side technology platform. So the answer is Jakarta JSON binding and making that a fundamental part of the platform. So just like JSON binding and Java serialization in the past, this is basically a POJO-based model that just works, right? The idea is that you should be able to very easily transform back and forth between JSON without needing to do anything at all, and you'll see that in the example. There are a small set of annotations that allow you to basically override default behavior, right? So maybe rename a property or mark something as transient so that it's not actually sent out in the wire, right? Those are the kind of changes that annotations that are there. But by and large, the idea is it just works with the POJO, right? So one of the very interesting things is that this allows the possibility of integrating with other APIs like Jakarta REST, right? So when you're integrating with Jakarta REST, all you really need to do is mark the outbound or inbound data type as application JSON, and that automatically triggers the Jakarta JSON binding API to come into play. Right? In fact, this kind of thing was available as of Java EE 7 in most runtimes, the JSON binding. But what it was is that they did this with proprietary APIs, like non-standard APIs like JSON. So in this case, you don't have any dependencies on JSON. The dependency is essentially on a standard-based API instead that allows you to do port from one runtime to the other very easily. Okay, so here's an example. The simple example is that I have a RESTful endpoint. It consumes a GET request and produces an application JSON. As you can see, it's producing the person POJO. I don't need to do anything at all. I just have a POJO. I do whatever I need to do for the POJO, and I return it, and it automatically translates into a sensible default JSON output because of the Jakarta JSON binding API. Okay. So prior to Jakarta JSON binding, there was another API called Jakarta JSON processing that was introduced in Java EE 7. So this API is more helpful in cases where you want to do lower level processing. So this is a same difference between, let's say, JAX-B, which is a annotation binding API, and JAX-P, which is a processing API. So similar type of idea is here. If you want to do lower level JSON processing, let's say you have a very complex document and you only want part of that document to be processed, or a very complex POJO and you only want to maybe hydrate part of that. Or if you have highly customized bindings that change at runtime, right? Those are all cases where having a lower level API makes a lot more sense as opposed to a binding based API. Now this API as of Java EE 7 was largely feature complete. There was a few things that were added though in Jakarta EE 8, and that is again to adapt to changes that are happening in the JSON standard itself, right? So two particular changes, namely JSON pointer and JSON patch. Okay, so let's talk about JSON pointer. So JSON pointer is basically XPath, if you're familiar with XPath, and even if you're not familiar with XPath, it's just like a URL, right? So it's a URL-like syntax that describes a location in a JSON document, right? So as you can see, this is I have an example of navigating to a mobile phone number, right? Just using a URL-like syntax. So what this allows you to do is that it allows you to navigate JSON content much more easily, right? Without this API, you'd have to write complicated looping logic, complicated tree traversal logic to get to the same bit of data. So it cleans up your application code quite a bit and makes it a lot more functional, if you will. Basically, the example that you see the example change that you see is the one on screen, right? So you just describe a JSON pointer, and then the runtime will get you the exact value that you need. The other change that's interesting is JSON patch. And JSON patch, in some ways, it has parallels to HTTP patch, right? So basically, it is describing a change to a JSON document inside of another JSON document, right? So the format is like the one you see on screen. So there is an operation, and there's various types of these operations. There's a add or replace or remove, move, copy, test. Right? These are the different operations that are there. And then you basically are using those operations to operate on mostly JSON, actually JSON path operations, right? So as you can see, I have a couple of examples, one replace example and one remove example. Crystallize this is how it looks like, and this is how the corresponding API looks like, right? So the API uses the builder pattern, right? And again, notice how compact this API is, and imagine how this code would look like if you were to do this just by navigating the JSON document as opposed to just applying a simple patch. Another really nice use case for this patch functionality is if you have the same set of changes that you're applying to different kinds of JSON documents, or at least maybe different instances of the same JSON document. Right? So this is also very helpful functionality in that regard. Okay, so server-sent events is the last API that I'll talk about. That is along the lines of HTTP and web standards support, right? So server-sent events is a lesser-known part of HTML5, right? This came out when things like WebSocket came out, right? So in Java E7, we adopted WebSocket, but server-sent events was adopted in Jakarta E8, just based on to see, okay, how does the adoption of these technologies actually look like before standardizing them. So server-sent events is something in between just raw HTTP requests and full-scale, multi-dimensional, bidirectional asynchronous communication through WebSocket. Right. So WebSocket is like socket, so it's like TCP, and we already talked about HTTP. Right. So it's a single request and single response paradigm. So in this paradigm of server-sent events, what you get is you still get one initial request from the client to the server, but the server doesn't respond in a once and done fashion. Right? What the server does is that it responds with multiple responses or multiple events over a period of time. Right? So an example of this is stock tickers on monitoring applications. Let's say you want to monitor the status of a control system, or you want to monitor a particular stock. You register with an endpoint, and that endpoint will tell you what the changes of that particular data is over a period of time. So fundamentally, server-sent events is really nothing much more than just plain long-lived HTTP. Okay. The only difference is the content type. So the content type is of type text/event stream. Okay, that's what denotes. That's what makes server-sent events different from just plain HTTP. Now, these changes are coming to you via Jakarta REST 2.1. And in fact, if you've used Jersey, right, which is used to be the reference implementation for JAX-RS, now it's also just part of the Eclipse Foundation, another project in the Eclipse Foundation. There was actually already an API as of Java E7 to do server-sent events in Jersey. The API that you see here, and I'll show you the API in a second, that API is actually very similar to what was in Jersey. So let's take a look at an example. So this is a stock ticker example. This is tickers. So you're making a GET request to register with this endpoint. And once you do that, this endpoint is not going to give you just one response. So hence you see that it is of type GET, but the response type is actually void. Right? So you're not just getting one response. You're going to get instead a set of responses over time. So the way this happens is that you get a handle to a couple of important APIs. One is SSE event sync, and this represents the live connection between the client and the server. And SSE is just a utility object that allows you to create new events, just like you see in the example. So in my example, once I get the GET request, I'm putting it in a background managed thread using the managed executor service in Java EE. As you can see, I'm using Lambda here. It works quite well, with most Java EE APIs. And basically, I'm sending events down as I encounter changes in my system. Okay, so I'm going to move on to Jakarta Security next. But before I do that, I just want to stop and see how things are going. Let you answer any questions that you might have, and also see if you would like to chat about any of this. Otherwise, we'll just keep moving forward. Okay, so I don't see any questions as of yet. right? I do see there's a couple of folks logged in, so I'll just continue talking about the changes that are in Jakarta E8. We'll talk about Jakarta E9 in a second, and maybe we can talk a little bit about what is next in terms of Jakarta E10. So Jakarta Security is a pretty important API, and it's a version 1.0 API, right? And when I say that, some people are surprised. It's a technology that's almost 15, 20 years old. How come you have version 1.2 of the security API? And how was security API was done in the platform before? Well, for those of you who are familiar with Java EE, you know the answer to that. So Java EE, what happened in Java EE is that there wasn't a single API. Every single API, like Servlet or EJB, had bits and pieces of security in it. And also, a majority of the security configuration happened outside the application, not in the application. So the application would simply say, "Hey, I want this application to be secure. I want it to be secured through, let's say, basic authentication. These are the roles that you can access this URL or access this particular method." But things like, okay, so I want to configure against a database or LDAP, or how's my role mapping is going to look like. All that usually happened at the application server configuration level. Right? So either through some kind of UI or some kind of XML configuration file at the server level rather than the application level. And that model, there's a reason why that model existed, right? So that model existed primarily to take the responsibility of configuring security out of the hands of the application, out of the hands of the application developer, into the hands of system administrators, right? So, or at least have a demarcation of roles, right? Where majority of developers don't deal with that aspect, and maybe there's a certain set of other part of the team that deals with that aspect of securing the application. And that model may continue to make sense, right? But the model creates two different problems. Number one, the security configuration is outside the application. So again, the application developer doesn't have control over it. And all of the server-specific configuration is done in a vendor-specific way, right? So if you configure security once, through some vendor-specific mechanism, let's say a UI, and you move your application server, well, you have to redo that in the other application server using the other application server's mechanism, rather than simply be able to port the application as is. Okay, so Jakarta Security addresses these weaknesses, and it does that in a couple of different ways that we'll talk about in a second. But one of the key things is providing simple security providers for common use cases like database and LDAP. Providing a simple pluggability mechanism where these common use cases are not sufficient, and also providing a universal security context that takes all those little bits and pieces that were there and unifies it in a single place. Okay, namely in the Jakarta Security API. Okay, so here's the simple security providers. This is a very good example of simplicity, right? Of introducing simplicity into the platform. So all those complex configurations that you used to do before, you don't need to do any of that, right? All you need to do in order to secure an application against a database or secure against LDAP is just put in this one little annotation, and you're done, right? There's nothing more to do. There's nothing more to configure in order for authentication and authorization against these endpoints to actually happen. Now, let's say for a second that you're not securing against the LDAP and you're not securing against the database. Let's say you have maybe text files where your security is configured, or some other legacy-based system that says neither a relational database or a LDAP server. Maybe it's in a NoSQL database, right? So what do you do in that case? So the way you used to do that in the past is you have to write a complicated JAS module, a JASPIC module, configure your app server. Again, a lot of vendor-specific configuration. Using the Jakarta Security API, it's super simple, right? So all you need to do is you need to implement the identity store interface. You need to make it a CDI bean, and that's it, right? It becomes a first-class security provider right out of the gate as a result. And there's just one method to implement in the end. It's just validate. It'll take some kind of credential as an argument, usually a username and password of some kind. And then you basically will take those credentials, validate them against your identity store, okay, and send along the results. So the result will be either success or failure. If it's failure, then maybe a failure reason. If it's success, then probably the name of the logged in user, and maybe some of the permissions that they're granted or some of the roles that they're granted. Okay, so security context is an important one too. As you know, again, you used to be able to get information like, okay, who's logged in and what is their role in a very API specific way, and only in certain points. So maybe only in EJB, right? And only in servlet, and that's about it. Let's say you have a security need to do security at the DIO layer, where you can't really do that very easily. So in order to solve all those problems, now you have a universal security context that you can inject anywhere. That can be in servlet, it can be in CDI, it can be in EJB, wherever CDI is enabled, you can inject it. Once you inject it, you get the information about, okay, who's currently logged in and what is their current roles, right? So you see that in the example. In fact, in my example, I have it implemented in a CDI interceptor so that you can apply this interceptor anywhere you would like on your code, and maybe globally enable it, right? For every single method invocation, CDI method invocation, this could be triggered for you. Okay. So moving on, I want to talk about another sort of change along the lines of simplification, and that's Jakarta CDI 2, right? So as you can see, this is a major release. So the major changes here are actually Java SE support. So CDI used to be a Jakarta EE only technology. So there was no standard way of bootstrapping it, let's say in a unit test or in a servlet environment or some other place, right? So now you can do that. There's actually a Bootstrap API to use CDI wherever you want, whatever it is that you need. Again, primarily maybe in unit tests. And the way you do that is there's also the notion of modularity. So there's a certain set of features that will only work in a Java EE container. There's a certain set of features that are core, that work anyway, and then anywhere, and then there's a certain set of features that will only work in Java SE environments. Asynchronous events is another one. I'll show you that in a second. The other big change was there was a lot of improvements made to the extensions API. So if you work with the early versions of the CDI extensions API, it's actually a little bit painful to work with, right? It's designed for, let's say, framework writers or software, commercial software developers rather than IT software developers, end user software developers. So a lot of that has been changed so that ideally anyone can write a CDI portable extension. In fact, you should give it a try. It's actually quite nice to write. The other change was Java SE 8 alignment. So these are things like absorbing repeatable annotations and the datetime API and completable features. Okay, here's an example of asynchronous events. Hopefully you've seen synchronous events in CDI before. CDI has a very nice built-in mechanism for object-oriented type-safe way of managing events. You know, it's just one method that says fire, and you give it an object that is representing your event, and then you observe that event using the @observes annotation, and that's it. Right? That's as simple as a CDI bus gets. The CDI bus used to be synchronous, right? So event firing and event reception used to happen in the same thread. So now you can do that in different threads, and that will help scalability. So you can say fire async and observes async, and then both the firing and the observation of the event will become asynchronous, right, as opposed to remaining synchronous. Okay, so I'm going to stop a little bit now before I talk about the last important theme in Jakarta E8, and that is adopting Java SE innovations. So let's see if you have any questions or if you want to have a chat on any of the things that we talked about. Okay, so I have a question from Sajid. SSC is similar to event-driven? Sort of, right? So event-driven is you can say, yes, SSC enables event-driven programming on the client side. Right, but it in and of itself is not defining the entirety of event-driven architectures, right? So it's a small part of event-driven architecture, certainly. Okay. Any other questions? Okay. Well, if not, I'm going to continue moving on, and let's talk about some of the innovations in Java SE that were absorbed by Jakarta EE and why that's important to you. So in reality, a lot of the changes that were made in Java SE 8 were made in a forward compatible fashion. So what that means is, if you upgraded to Java SE 8 and you began to use Java SE 8 features, most of those features actually will work with older APIs as is. You saw an example of that, right? So I used the executor API with lambdas, right? And it didn't require any changes to the executor API for that to happen, because executor API already is callback based, right? So anything that is callback based is probably going to naturally work with lambdas. Similarly, if you want to adopt things like the datetime API, you can very easily do that in your business logic. There's not a lot you need from the runtime in order for that to happen. Same thing with completable features. But there's some cases where you actually do need the Jakarta EE API to adapt, right? So one key example of that, we'll see a few examples of this, right? And these are the changes that are listed. So repeatable annotations actually changed a lot of APIs. So things like persistence, messaging, mail, bean validation, they all adopted repeatable annotation, CDI as well. Datetime API, again, the changes, the APIs that changed as a result were faces, persistence, bean validation. Completable features were adopted by Jakarta REST, and streams were adopted by Jakarta Persistence and Jakarta JSON processing. So let's take a look at what these changes actually mean. So we'll first talk about repeatable annotations, right? So repeatable annotations solves the problem of being able to have the same annotation at the same place, right? So this didn't used to be possible. So in order to solve this problem, Jakarta EE typically used this technique of using wrapper annotations, which is kind of a hack, right? So and you see, hopefully have seen this already. Use things like named queries is a pretty good example. So as of Jakarta EE 8, that is no longer necessary, right? Because all of these annotations have been retrofitted to make use of repeatable annotations, right? So you can just, as an end user, just repeat these annotations where you would need them. Right? So it cleans up the API, cleans up the code quite a bit. So again, all of the APIs like JMS, Java Mail, anything that where multiple annotations, this possibility exists, those have all been adapted already in Jakarta EE 8. So the datetime API, similarly, again, you can use the datetime API anywhere you want, right? Wherever you need those additional capabilities, you can use them. But a problem it will come in if you're using something prior to, let's say, Java EE 7, and you're trying to use datetime APIs. Let's say in an entity, like in my example, you wanted to use in the instance class, right, to represent a particular event in time. Well, you won't be able to use instance because JPA will not know how to translate instance back and forth between the database, right? So, but in Jakarta EE 8, this is no longer the case, right? So Jakarta EE 8, now JPA understands all these datetime APIs and can translate them without your needing to do anything. So you can just use it the same way you are going to use Java util date or Java SQL date. And similarly, the bean validation annotation, which I have an example of here, that also recognizes these datetime API classes automatically. So you don't have to do anything with that. Same thing for JSF, right? So if you don't have to write a converter or anything to convert back and forth between these date classes and let's say faces backing beans. Okay. So completable features, I hope you guys know what this is, but this is basically the promises for Java, right? So if you're familiar with JavaScript promises, basically it takes the best parts of future and merges it with callbacks, right? So you have the capability of making asynchronous invocations without prematurely blocking or writing very complicated code. Right, so you see an example of this in here, where I'm making a couple of invocations. So I'm getting somebody's social security number, and getting somebody's assets and liabilities, and these are potentially time-consuming REST operations. I'm getting a handle to a completion stage, so it looks like future, but then it uses a composable callback-based API, like then combine, as you can see in my example, that allows you to do this kind of complex asynchronous invocations in a very fluent, functional way, right? So now the Jakarta REST, there's a particular usage of this in Jakarta REST, both on the server side as well as on the client-side API. So in the client-side API, all you need to do is invoke .rx, and instead of returning a future or doing callbacks, you'll get a handle to a completable future instead. Okay. So streams, again, hopefully you're familiar with this already, right? It allows you to do all kinds of aggregate operations in Java that you didn't used to do before. You either had to get a third-party library or be able to handwrite a lot of this code, right? So you don't need to do that anymore. And also, the Streams API makes heavy use of functional paradigms. It's actually one of the better examples of an API adapting functional paradigms. So the Jakarta Persistence API, as well as the Collection API, or rather the JSON Processing API, allows you to translate to streams very easily, right? So now, for example, you can do things like what you see on screen, right? You can get a stream directly from a query and manipulate those results, right? So same thing with arrays of JSON, right? You can very easily translate them into streams and perform operations on those. Right? Do use this with care, right? So I've seen cases where people suddenly think they can use streams as a replacement to the where clause or the order by clause, right? That's usually not a good idea. As good as streams are, even with some of the multi-threading capabilities, the database optimizations often will outperform, right? Anything that you can do in Java middleware. So do use it with caution. Okay. These are not all of the changes. These are just the high-level changes in Jakarta EE. There's many other such changes as well. So here are some examples of those that I won't talk about in great detail and won't show you example code too much. So now you can do very easy WebSocket integration with JSF. You can do JSF and CDI integration. So as I said, injecting things like faces context, you can do that very easily. There are more bean validation constraints that were added, so things like email validation, not empty, past, future, and there's a few others like that. In my example, I showed you one point-to-point communication between SSE. It can be one-to-many communication, so you can broadcast SSE events. So you can have basically multiple clients connecting to the same endpoint and getting the same result. Right? That is also possible in using the SSE API. You can do things like CDI event ordering, in addition to being able to do just asynchronous events. Similarly, you can prioritize injection points as well. So this is the add priority annotation. And as I said, the Jakarta Stream support is also there in the. I didn't mean to say. Let me correct this slide right now. I meant to say Jakarta JSON processing. Okay, all right. Okay, Jakarta JSON processing. I didn't show you an example of that, but you can do that as well. All right. So state of Jakarta 8 implementations, pretty much all of the runtimes are today Jakarta 8 compatible. The only one that remains is WebLogic. And the next revision of WebLogic is also going to be Jakarta 8 compatible. So pretty much all of the one major platforms will be Jakarta 8 compatible. You can begin to use that and begin to use the new switch over from Java EE to Jakarta EE, and begin to get ready for the future. Okay. So speaking of the future is immediate future is Jakarta EE 9 and Jakarta EE 9.1. Okay, so what is this about? As I mentioned, the primary objective here is to move away from the JavaX namespace that is still under Oracle's branding regime to a truly open namespace via Jakarta. There's also some other changes. So removing all of those things that I said was pruned, well, they're now actually gone. It's primarily intended for tools ecosystems and early adopters that want to move to the new namespace in preparation for Jakarta E10. That gives you a little bit of space to do that. It's all but done. right? So there is a milestone release out. You can begin testing it. Glassfish 5 is already out. You can begin testing with Glassfish 5 and see how the namespace changes look like. The big change between this is really just make sure that the namespace transition is smooth. There's a lot of actually community contributions that happen to do that. The Jakarta EE ambassadors have facilitated that by writing a guide and also helping people contribute to these standards. The work is almost done now, but you can still check to see if there's some work that you can contribute. Certainly your contribution is welcome here. So Jakarta E9 is going to remain targeted to Java SE 8, right? Just to not create too many changes all at once. But early next year, there should be a Jakarta E9.1. And the primary objective of 9.1 is going to be to support Java SE 11. Okay. In fact, most of the Jakarta E runtimes today, like OpenLiberty and Pyara, they already support Java SE 11. And in fact, so does WebLogic. Right. This is probably, hopefully, not a very big deal. Right. If you want to use Java SE 11, you can already do it. 9.1 will formalize that. Yes, any Jakarta EE in 9.1 runtime is going to support Java SE 11 as well. Okay. So hopefully in this conference, you've also heard of MicroProfile. I won't talk too much about it, but basically, it's taking a little bit of time to do all of the transition and do the transition cleanly from Java EE to Jakarta EE. So there's not a lot of time for a lot of innovation. So the innovation space is MicroProfile, at least for now, right? So it's, as I said, Jakarta EE in general is a pretty good solid platform if all you're really writing is a monolithic application, and that's all you plan to write, and that is good enough for you. But if you want to go beyond that, and if you want to adopt microservices in a wholesale fashion, right, and be in the bleeding edge of microservices development, then you need to look into augmenting Jakarta EE APIs with MicroProfile APIs. In fact, most of the Jakarta EE runtimes will allow you to use MicroProfile. They also bundle MicroProfile just like they do, just like they have built-in support for Jakarta EE. And there's a number of features that are available that are microservices oriented. You should definitely take a look at that. Even if you don't wind up using microservices right away, it's useful to be aware of what these innovations are. Okay, and the way you find out more about that is log on to microprofile.io. All right, so now that you have the Jakarta EE transition almost done and the namespace almost done, and you have this microprofile, a natural question to ask is like, how do you align both of these technologies? And this has been something that I've been thinking about for a while. So the way I've thought about this is basically talking to people that I know and trust, they're Java EE users, and listen to what they would like to see. And also to take advantage of my Twitter following, right? To see, hey, what do the people that follow me on Twitter, what are their opinions on this? And the opinion is actually very, at least somewhat surprising to me, right? So they really don't want two different things. Everybody just wants one platform, not MicroProfile and Jakarta EE, but just one platform. And they do believe that one merged platform should remain Jakarta EE, right? Even down to the namespace level. Right? Even if you ask people, hey, what type of namespace? Does the branding and namespace need to be can they be two different things or the same thing? The answer is overwhelmingly, again, the same. People seem to really want just one uniform API that is standards-based as opposed to two different things, right, that they have to think about and be aware of. So if you have an opinion on some of this, you should engage the Jakarta EE community. You should engage the MicroProfile community and make sure your opinion is heard. Right. So if your opinion is not heard, it's not going to be listened to either. Right. So that's the first step, is saying what is it that you want and why. I'm going to stop a little bit now and see where folks are. Then we'll move on to another pretty big topic. I have another hour or so to in this slot. I'll talk more about Jakarta E10 in a little bit more detail, and I'll tell you why. But before that, I just want to stop a little bit and see where you guys are and see if you have any questions. See if you'd like me to bring you on screen and maybe have a chat. It's up to you. But I don't see any questions, so I'm just going to keep moving and keep moving forward. Okay. So these are the possible. So after Jakarta E9 is done, hopefully by this year, this opens up the possibility of innovation, right? And this was the whole point of why we did these things, right? To speed up the innovation in Jakarta E. So these are some of the possibilities, and these are things that you know, a lot of us in the community, you know, we've been wanting to do in Jakarta E for a little while. So these are things like Jakarta NoSQL. This used to be called the Eclipse JNoSQL project. What this does is that it gives you a JPA and JDBC like API to access NoSQL data stores like MongoDB, Cassandra, and so on. So this is a possibility of where this could be a brand new API added in Jakarta E10. Similar thing for Jakarta MVC, right? So this is an alternative to JSF that looks more along the lines of struts. Let's say it's an action-oriented framework. People have been asking for such an alternative in Java EE for a little while, right? So they don't want to just get out of Java EE just to be able to use action-oriented frameworks. They wanted a framework choice just like this. Again, it was started as Java EE MVC, didn't make it in the Java EE timeframe, but it's finalized now, right? And again, another possibility is to add Jakarta MVC as part of Jakarta E10 as a brand new API, deprecating some of the old things, in particular deprecating EJB. It's an outdated programming model, and it's basically redundant with CDI. So what you can do here is you can move a lot of the functionality that is in EJB and make it CDI based and move it into other specifications like messaging and concurrency and security, where they actually make more sense, right? So we saw that the Jakarta Security API supports things like LDAP and database. In reality, especially with microservices, there are other authentication mechanisms that are also very common, right? So these are things like OAuth 2 and OpenID Connect and JWT or JSON Web Token. So these actually make sense to standardize in Java EE as well, right? So that Java EE developers have built-in support for these APIs. There's some Java SE alignment still left to do, right? So, for example, the Jakarta Concurrency API could take better advantage of the completable futures. Similarly, Jakarta Persistence could take advantage of records in Java SE 11. So there's a few bits and places where still some Java SE alignment work is necessary. CDI alignment, definitely there's a lot of space for it, right? So number one, we already talked about maybe getting rid of EJB altogether. And making everything CDI based, all of those services CDI based. Similarly, there are places like batch and concurrency and REST that could be better aligned with CDI, right? And there's also configuration. So, well, if you have time and interest, I'll after I finish this particular segment, there actually is a document that the Jakarta EE ambassadors have drafted. Would be very good to get everyone's input on that document. I'll walk you through that document in the latter part of the presentation once we're done here, so that you have an idea of what are the possibilities in Jakarta E10, and two, you can provide your own opinion and also maybe help implement some of those changes yourself. Like I said, if there's one thing that you should take away, is that you need to get involved, right? So that brings us to the Jakarta EE ambassadors. The Jakarta EE ambassadors is basically, we're not vendors. It's really just a grassroots level people that contribute their own time, right, to help advance Jakarta EE together. You can get involved with the Jakarta EE ambassadors very easily. And it is an easy way for you to even do simple things like begin evangelizing, right? Maybe delivering this talk somewhere, or writing a blog entry on Jakarta E9, or writing a blog entry on a possibility that you'd like to see for Jakarta E10, or maybe even contributing. So many different ways of contributing. And the Jakarta EE ambassadors is a place where you can come together to get help on how to do those things. So there's a website. If you want to learn more, jakartaeambassadors.io, and also actually one of the best ways of keeping track of what's going on with Jakarta EE is just to follow the Jakarta EE ambassadors Twitter handle. That's outlined there as well. And if you do nothing else, hopefully you can just follow the Twitter handle, and that is already an improvement, something something that you can do better as somebody that sees the value in Jakarta EE as a technology. Okay, so Jakarta E8 is very significant. It's significant in terms of opening up the platform, making it, putting it into open governance. It is also technologically interesting. There's a whole bunch of interesting things that are built into the platform. Jakarta E9 and 9.1 are coming soon, right? So they're right around the corner, and they're another step in the transition towards openness, and followed by Jakarta E10. But ultimately, I really hope that the main thing you take away from the talk today is that you need to get involved, right? And you need to contribute, and you need to see what's going on. Okay, so I'll leave you with a few resources, and I'll end this particular segment of our session, and then we'll move on to the next one. So the next one is going to be walking through the changes, the document draft that we have for Jakarta E10, and showing you what the potential changes might be, and maybe hopefully get some of your input. So if you want to learn more about Jakarta one of the really nice places is the Jakarta EE live stream recordings. Right? So a lot of what we're talking about actually has been talked about in greater detail in those recordings. So log on to jakarta1.org, find the recordings. They're actually on YouTube as well. And you'll get a lot of information just by taking a look at those videos. If there's one place where you really should get engaged in terms of an email list, that is a Jakarta EE community alias, right? So you should log on there and register yourself and become an active contributor in Jakarta EE. And of course, there's the official Jakarta EE Twitter handle in addition to the Jakarta EE Ambassador's Twitter handle. Another really nice resource is sort of a virtual jug for Jakarta. It's called Jakarta Tech Talks. There's usually monthly talks in the Jakarta Tech Talks, and again, the Jakarta Tech Talks have a bunch of recordings as well. And you can join there and basically subscribe and see what are the topics and sessions that interest you, and you can stay up to date that way as well. All right, so that is it in terms of this presentation. I'm going to show you where this presentation resides. Okay, just to encourage you to maybe make this session yourself, maybe present the session yourself. And I hope you can still see my screen. So this is the Jakarta Ambassador's website. If you go to the resources section, and if you go to the Google Drive, this is a shared drive for everyone that is a Jakarta Ambassador. Over here, you will see there's a presentation template, and this particular deck that I just presented is Jakarta EE8.PowerPoint. Right? You can open up this PowerPoint and actually download it and make your own alterations and adopt this deck yourself. Okay, so hopefully that is helpful and something you will consider doing. So let me stop the presentation for now, and let me just double check with everyone, see how folks are doing. So anybody want to come on screen and have a chat? Do you have any questions that I can help answer? No? Nobody has any questions? Okay. All right, let me keep going. Then what I'm going to do is show you the document draft that we created. Okay, so let's see how we get to that. So I'm going to log back onto the Jakarta Ambassador's website. So the way you get there is you hit the Getting Involved button. Okay, and you'll see in the Getting Involved section, we've outlined all of the different things that you can do as an individual to help move forward the Jakarta EE as a technology. And under here, you'll see that we have linked an early draft contributor guide for Jakarta E10. So you can click on here, and it'll bring you to a Google Doc. Right? And the Google Doc is open to anyone, especially open for comment. Okay, so you can take a look, you can read this document, and it will tell you, how you can become a contributor to Jakarta E10, and more importantly, what are the changes? What are the types of changes that you can get involved in? So I'm going to begin to walk through this document for you. Unless you have other questions, right, or something else that you would like to cover, I'm going to take a little bit of time to basically discuss this document and go over it with you. So let me do full screen. All right. So I hope you can see the text here. Otherwise, I'm going to try to increase the zoom level a little bit. Okay, maybe that's too much. Let's do one more, 150. Does that work? No, that's too much. Okay. All right, 125 it is. So this is the guide to contributing to Jakarta EE 10. So there's many different ways of contributing to Jakarta EE. The simplest thing you can do is you can subscribe to a mailing list. So the way you subscribe to all of the mailing lists are available here. So if you open up this link, okay, it has a list of all of the Jakarta EE mailing lists that you can join. Right, beginning from CDI to EL to JSF, and a whole bunch of lists like that. And one of the ones is the Jakarta EE community list that we already talked about. So the first thing you can do is you can join onto these mailing lists and essentially you keep track of what's going on and contribute to the conversations there. Right. So this is how you begin to develop and begin to understand what's going on and begin to express your own interest, right, in a particular technology or maybe multiple technologies. So next, if there's a specific set of changes that you would like to see, one very easy way of doing that is first see if that issue is already documented, right? And the way you do that is you go to each of these Jakarta EE projects. So let's say we go to Jakarta Bean validation or Jakarta concurrency. And each of these will have some kind of link, right, that will take you to take you to the GitHub or where this project resides, perhaps in GitHub. So I think we go to here, perhaps. Okay, and here's where you have the GitHub account, and you'll see those GitHub issues, right? So each of these projects will have some issues that talk about future-looking changes and the kind of things that could be done. So, for example, add a asynchronous annotation to replace CJB, right? So these are the kind of things that you can do and see if your favorite technology is listed, right? Your favorite change is listed. If not, what you can do is you can log on onto the mailing list and begin discussing this change, and maybe down the line enter an issue and begin working on that issue, right? There's also the different sets of changes, right? So there's the API sets of changes in the API. So this is the API project, for example, concurrency API. If you look in the project, there will be an implementation project as well, and there will be a TCK project, right? So there's a number of projects that you can get involved in if you want to begin making a change, right? So begin making a change looks like propose an API change, do a TCK change the actual implementation, typically something like Lostfish or Jersey or Mohara or OpenMQ or Eclipse link, maybe even provide a proof of concept. Right? These are the kind of things you can do. If you're unsure about all of that, right, and you really don't know where to start, one easy way to start is to just reach out to the Jakarta EE Ambassadors Google group. That's here. Okay, you can just introduce myself, like there's somebody that introduce themselves and say, hey, I want to help. This is my background in Jakarta EE. What can I do, right? Where do you guys need help? And if I'm interested in a particular thing, how do I go about doing it? So for the most part, actually a lot of the stuff you'll be able to do without any kind of paperwork as well, just as a normal end user, right? So there's no reason to sign paperwork just to follow a project, just to file an issue, just to participate in a discussion, right? But if you do anything beyond that, and you begin to want to contribute some code or contribute a change, you will need some paperwork. And even in that, paperwork is not really that heavyweight, right? So if you don't want to become a committer and you just want to contribute some code, all you really need is something called the ECA, or Eclipse Contributor Agreement. So I'll show you how that looks like. This is it, right? It's a simple document. You just click on some links here, and it takes you to the ECA form, right? So I'm logging in as myself here, and you just sign the agreement, right? I've already signed the agreement, so all you need to do is sign the agreement, and you're good to go. That's all you need in order to contribute code. Now, if you want to do something beyond that, and let's say you've contributed quite a bit, and now you want to become a committer on a project, that will require some more additional paperwork, right? And that paperwork will often require some permissions from your employer, right? So sign the ECA, you don't need it. If you want to become a committer, more than likely you will need to work with your employer. The contributor guide actually has some links on how you do that, right? If you want to become a contributor, there's a FAQ that will walk you through that process as well. So let's talk about what the Jakarta EE contents are. We talked about that as well. There's no official roadmap for Jakarta EE 10 just yet. There's some high-level directions that were put together, but that's really about it. So ultimately, it is really up to you. It's up to each individual technology project what type of changes they would actually like to see, right? So the best way of determining this is to get involved and get your voice heard, and hopefully begin to contribute some of these changes. So there are some key themes that you can take a look at a high level. So aligning CDI is one of them, right? So getting rid of EJB perhaps, and more flexible, modernized CDI-centric equivalent functionality, introducing that. Aligning more and more specifications with CDI where it makes sense. So I talked about Jakarta REST, for example. Aligning to Java SE, right? Those are those few bits and pieces that we talked about, where Java SE innovations can be better adopted by Java EE technologies, and also breaking up and making every single technology that is fundamentally could be available to in Java SE, making that available in Java SE. Right? There's no reason not to do that. The more you do that, the greater usage these technologies are likely to have. Right? If you can use it in more places, it's a good thing. There's some other vendor-neutral things that would be better standardized to achieve better portability. So this is another key theme. So at the platform level, these are some of the changes that you can think about. So the TCKs today are very, very old, right? They're used, pardon me. The TCK is about 15 years old, right? So it's written with very, very old technology. All of the TCKs can be modernized using JUnit 5 and Archelion, and actually my friend Andrew did a very good write-up on this. You can take a look at it, and that's a important bit of work, but it's also very easy to do, right? It's just taking a little bit of older code and translating it into JUnit using Archelion. So there's a lot of work along these lines. Most of the TCKs have already been separated, so each technology can actually have a separate TCK. But there's a little bit more work to be done to finalize that. So this is another area where you can potentially contribute. We could introduce an @service annotation as a replacement to EJB stateless. EJB stateless is by far the most commonly used EJB annotation. You can replace that using @service that provides equivalent functionality. We could have more customized websites. So good examples are things like bean validation. So let's take a look at the bean validation. You see this is a Jakarta EE technology that has its own website. CDI is another example. So each Java EE technology can have its own website just like this, right? So that would help these technologies as well to succeed on their own right, as opposed to just being part of a broader platform. When you begin to look at the issues of each of the projects, you'll see a number of issues that are old and out of date. Okay, so you can help clean up and prioritize those issues as well. Right? That's a very easy thing to do, and it's a good way of learning and beginning to engage and beginning to contribute to these projects as well. Another thing that may happen is improving modularity support in the platform across all technologies. So there's bits and pieces of technologies today that support JPMS, or the Java Platform Module System. So all of these technologies could be made to better support that standard, and there's modularity itself could be standardized in Jakarta EE much better. Right. So the first modest steps to doing this is doing things like automatic module names in the manifest.mf and providing a correct module info.java. Again, very, very simple work. Right. You can log on to most of these projects and make a PR and provide these fixes yourself. Introducing a microservices profile. Right. This is another important thing, and maybe another way of aligning MicroProfile and Jakarta EE. Is by saying that the parts of Jakarta EE that MicroProfile uses, so things like CDI, REST on JSON, okay, that can be its own little profile, right? So that everything that is MicroProfile compatible also automatically becomes Jakarta EE compatible as well, right? That's another potential change in Jakarta E10. The security API already is pretty important, right? We talked about some of the potential other changes there. So again, adding support for OAuth 2, JWT, OpenID Connect, in addition to the database and LDAP. Providing EJB-based alternatives in CDI-centric ways. So replacement to things like roles allowed and run as, that could be done. One other idea that has been floating around for a little while is allowing a role-based EL-powered annotation to do authorization. Right, so you can see an example of that. So at authorized, if a principal's name is Arjan, right? So in addition to writing code for that, you could just do that in a more declarative fashion. You could provide an embedded security provider that is helpful for prototyping or helpful for unit tests, right? So this is an embedded identity store definition that could potentially be provided as well. Jakarta concurrency is another important one. There's a lot of pending changes here. Again, this could be another destination where EJB annotations like at asynchronous, at schedule, and at lock could wind up in, right, outside of EJB in a CDI-centric model. You could add other things that are today proprietary. So, for example, specifying maximum concurrency for a bean, doing managed executor service definition. Right, today you can only do that in vendor-specific ways. Adapting support for Java SE completable futures. So a lot of these APIs today are still based on Java util future. They could be retrofitted to use completable futures instead. Properly propagating CDI context. So today, when you create a managed executor service and you spawn a thread, the CDI context is not propagated. Right, so that could be an important change as well. Standardizing things like object pooling through the pooled or pool scoped annotation. That's another possible change. Messaging, again, this is another target where you can take MDB and create a modernized version that is CDI based and move it into Jakarta messaging. Jakarta messaging could be made better available in outside of Java EE and Java SE environments. So just like CDI, you could provide a Java SE bootstrap module and a standardized way of creating resources like queues and topics. You could think about doing interoperability between JMS and AMQP, or JMS and Kafka, or JMS and MQTT, so that these protocols also have baked-in support, a defined way of support in Jakarta messaging. Or you could also think about potentially Kafka implementing JMS, implementing a version of JMS. Right? So these are all, I think, very important things to think about. Jakarta Persistence is largely pretty mature, okay, but there's some things you can consider doing here as well. So persistence.xml can be made optional, right? You don't actually, in many cases, you actually don't need the persistence.xml. So that is potentially could be something that can be pulled out and made optional. You could add more SQL-like features, right? So things like subselects, right? These can be helpful in, for example, things like pagination. Adding JCache as a second-level cache provider, right? So today JPA has a caching mechanism, but it's proprietary. It's JPA specific. You can't use a JPA. You can use a JCache provider very directly with JPA, JPA secondary level cache. Maybe that could be standardized. Multi-tenancy. So things like Eclipse Link and Hibernate, they have different ways of managing multi-tenant databases. Right? That could potentially be standardized as well. Jakarta REST similarly has a set of changes. So using @inject instead of context for injection. This would be an alignment story between Jakarta REST and CDI. Again, providing a bootstrap API for Jakarta REST, potentially for doing unit testing. Right? You ought to be able to bootstrap Jersey in a unit test or in a Java SE application. Adding native support for multiplied form data. Right? This is today not really possible in Jakarta REST, but there are some legitimate cases where you would want to do things like this. In batch, again, today batch is basically uses its own API. It doesn't use CDI very much, right? It could be enhanced to align with CDI a bit better. Today, you can only define jobs in XML. So the job definition language can be moved from XML to Java, so that you can avoid using XML in one more case. And you could also do more flexible definitions. So today, the definition for readers, processors, and writers are a little bit rigid, right? So there's a specific way of doing things. And instead of doing that, you could make it a little bit more generic. Jakarta Mail, if you've used it before, it's a very low-level API. It feels a lot like JDBC. There could be a space for creating a higher-level CDI-based API for Jakarta Mail. Okay, so one very easy place that you could do this kind of work is something like Apache DeltaSpec. Right, the Apache DeltaSpec project, you could create a model there that supports Jakarta Mail specifically. Transactions is another interesting place where there are certain things, certain optimizations. For example, using one-phase commit or last resource utilization. These are common optimization techniques in runtimes like WebLogic that improve the performance of JTA. Those could potentially be standardized so that all application servers actually have that optimization to make JTA more performant, specifically in microservices environments. Faces has a set of changes as well. Right, so you can make more REST-friendly URLs for faces. You can certainly deprecate some of the older APIs, that are in faces. Things like support for JSP. Right, so JSP can remain a part of Jakarta EE, but the support for it in faces could be dropped. Largely, this is replaced by facelets. New APIs we already talked about, right? Jakarta NoSQL, Jakarta MVC, and potentially configuration. These could be new APIs that are introduced in Java EE. I've added links to the mailing list and the project for all of these. Specifically NoSQL and MVC, they could use some engagement and evaluation. Right, you could get engaged in these projects and see how they're doing. How does it look like? You can also get involved in non-specification projects. Right? So aside from the specification project itself, there's a tutorial. There's the examples, and there's also cargo tracker. Right? So these are not as technologically advanced as trying to contribute to a Jakarta standard. Right? Most of us, I think, can write tutorials, right, or write some examples, or write an example application using end-to-end example application using Jakarta EE. So these are good candidates for those type of contribution if you're interested in that. So we should also talk about what is beyond Jakarta EE 10. Right? So there are also a certain set of changes that you could think about after Jakarta EE 10 is done. By the way, there's a possibility that Jakarta EE 10 may be done by next year. Okay, so these are some of the things that are beyond that. Let's say aligning JPA with Java SE records, adding schema, so JSON schema support in JSON processing and JSON binding. Today, this cannot be standardized because JSON schema itself is not final yet. Adding more reactive capabilities, or maybe not. Right, taking a look at what is going on in Project Loom, and then aligning with Project Loom to see how you add more reactive or non-blocking features in things like servlet. or JPA, or many other places like REST, MVC, messaging. Potentially moving Archelion from a Java-specific project, or rather a Red Hat-specific project, into the Eclipse Foundation, right, as a key part of enabling testing for Jakarta EE. Right? That could potentially be done. You could create a native compilation profile. So things like Micronaut, or perhaps even Quarkus, can become Jakarta EE compatible, right? So better support for things like GraalVM and native compilation techniques in general. So these are some of the ways, some of the things that you can contribute, and some of the key ideas for Jakarta EE 10 and perhaps even past Jakarta EE 10. I hope you'll take a close look at this document that I overviewed for you today, and think about how you could contribute, or in general, see if there are things that are missing, things that are valuable, and the like. So I think that is really all the time I have. I'm gonna stop sharing temporarily. So let me see if there's any other. Will NoSQL specification be added to Jakarta EE 10? Potentially. It could be added. So let me stop sharing my screen. It could potentially be added in Jakarta EE 10. It's not a sure thing, but this is a place where developers should engage and evaluate what the technology is, and see what the right thing to do is from a platform standpoint. Okay, so that is all the questions that I have. I'm going to stick around a little bit, but I'm going to turn off my video, or I'll keep my video on, and see if there's any other questions. Anyone that would potentially want to come online, come on the screen, and have a chat with me. It's really up to you.